I was kind of planning to switch professions, maybe to start doing some hip hop and R&B, because I'm getting used to the mic. So that's my first joke. Yeah, people know me better. Usually, I do like to talk a lot and give some examples via jokes. I think that that's the most practical way how people will try to cope with what I'm trying to say to them, and at least take it not so seriously as maybe as a remark of what they are doing. My general purpose for this presentation is not to showcase some code base, etc., because I don't think that's why we are here. It's more, let's say, putting an aspect, what to expect with the new architecture of React Native, how to move forward, how to actually deal with all the challenges that will come with the new architecture, and how to accept this, because it's a very, very significant step forward in React Native. Something that is going to drive a lot of people away from React Native. That's first thing. The same happened with AngularJS previously, when switched to Angular 2+. So a lot of people were very, let's say, afraid what they needed to change. And usually a lot of people just stuck with the AngularJS, and there come the React afterwards. So a lot of hate went towards Angular. So just not to go in a direction that the new architecture of React Native is just going to promote more Flutter or other cross-mobile platform development tools. So just to be aware, this is the type of presentation that I'm doing. So I don't know, maybe I can start with the first slide. Okay. So I'm not used to the pen, so I will use this. So that's the topic of today's lecture that I'm doing. This is me. I'm Blazhe Petrov, JS Tech Lead in Melon, recently part of Kin and Carta, together with Fracton. So that's a picture when I was a little bit younger. Yeah. So next slide. This is what we are going to talk about today. In basics, we are going to cover what is React Native, what is currently what we are doing with React Native, how React Native is actually working, and what are the key changes that comes with the new architecture of React Native. Actually, why this changes, what problems it solves, and how this can be actually used from us. So, and additionally, there is something extra that I want to share at the end of this session. So let's talk about what is React Native. So I don't know how many people here in the audience have worked with cross-mobile platform development tools. Okay. So the basic concept is that we develop a mobile application that is developed with a React framework. Basically, it's going to be compiled and executed on a different mobile platforms like Android and iOS. That's the concept of having a cross-mobile platform development tool like React Native. So how this happens? Usually with React Native, we have React Native components, and this is very important thing. These React Native components are going to be transferred to native views. That's the first stuff that is happening here. So we are not drawing HTML or whatsoever on the native views. We are compiling them to view groups, text view, image view, or UI view group, UI text view, depends on the operating system. And this is happening in the background. And additionally, we have the JavaScript code, and this is very important, that the JavaScript code is not compiled to a native platform language. As you know, JavaScript is dynamically typed language, and the native platform languages like Java, Kotlin, Objective-C, etc., Swift are something that are strongly typed languages. So it's very hard to compile JavaScript to something that is native platform. Why this is important is to understand how the entire ecosystem of React Native is actually working. So let's go to the next slide. So how the JavaScript code is understood from the OS, how all of this is working. I'm just going to try to illustrate this. So basically, what we have when we start to build our application is that we are going to have two folders that are generated for us. One is for Android, one is for iOS. And all the native code that actually is going to be executed on the real device is going to lie there. All the bridging, everything else is happening there. So we normally go and write our code in JavaScript with React Native, and then we want to run this. And actually what we are going to do is that we are going to execute some script, React Native run Android, or React Native run iOS. What this will do is that it's going to load the packager, and this, let me try this, and this packager is, this packager is going to take the entire JS code, and then once it takes the entire JS code, it's going to start the native UI treat. What happens in this segment is when the native UI treat is started, it looks for what is the platform that is running on. Is it an Android or iOS? When it finds what is the platform, it's actually going to run and find the index.file inside these two folders, and then run the representative structure from the folder structure that we have in our application. Is it an Android or an iOS? And this in parallel will then start a JS treat. In this JS treat, the JS, go back. In this JS treat, the JS code is going to be bundled and passed inside the JS treat. So now we have two parallel treats that are running in the same time. One is the native UI treat, and the other one is the JS treat. So everything that is our custom logic, business logic, that we have done, is going to run in this JS treat. And everything that is related with redrawing the view, representing what are our changes, is going to happen on the native UI treat. By default, JS treat is asynchronous, as you are aware. As a programming language, JavaScript is asynchronous. In order to have all these changes going backward and forward between the JS treat and the native UI treat, there is something called bridge. What this bridge is responsible of doing is actually doing all the communication between the JS treat and the native UI treat. So all the events that are going to happen on the native UI treat are going to be passed through the bridge to the JS treat, and everything that we are going to execute on the JS treat is going to be passed through the bridge to the native UI treat. All these event listeners, everything else will go through the bridge. So how this drawing is happening in the native UI treat is by using a concept of shadow treat. I know that some React developers are familiar with the shadow DOM and how this concept works. Here we have a shadow treat, and what this shadow treat is going to do is that from the JS treat, we'll take the serialized JSON, we'll decide how to draw the components, because the native UI part doesn't know how to work with flexbox, etc., etc. And we kind of create our components, if you remember the first slide, with React Native components. So everything there is with flexbox. So there are margins, heights, widths, colors, etc. All this nice styling. But the native UI doesn't understand that. So the shadow treat will actually do all the calculations, everything else, and will create these native UI components that will be afterwards rendered. But additionally, all the events and everything else will go to this serialized JSON and be passed. So what happens here is that we are kind of, if we put a single button and we want to represent it on the native UI treat, a proper event for some async listener will happen. Everything from this will be passed to the bridge. So an action on the native UI side again will trigger some event, then this will be passed to the bridge, and a lot of serialization, deserialization of JSON, a lot of recalculation of the UI will happen. So that's the main reason why we are kind of doing this presentation and what actually comes with the new architecture. So this bridge, it's a good thing, but also it's a how to say, a traffic jam spot. So everything that is going to happen between the JS side of the world and the native side of the world will be passed through this bridge. And what happens is, if you see some more complex applications, you will see that there is a lot of struggling with performance, especially with more demanding UI components like list views or etc. And when you start using some gestures, things like that, things are getting out of hand. So basically a lot of drop of performance is happening because of how JS is actually working. And this is not a wrong concept. Back in the day when this was introduced, this was considered to be the way moving forward. Because as we know, React is something that is being promoted or built from Facebook, and they built their technology based on their needs. So this is not built in mindset that we need to create games, complex animations, etc., etc. This is built in a more functional way, concept of doing things. So comes to the next slide. I discussed some of the problems that currently are basically with the performance. This is how the old architecture or what is happening on the old architecture as an overview. So we have the React.js part when we have a normal tree view from React elements. This is JS type of tree view. So we have root, view, text, etc., etc. All of this is going to be transferred to the shadow tree, and this is going to be written in C++, the React shadow tree, and all of this is going to get representation there. And then through the bridging, it's going to go to the host view tree, the native view tree. And this is going to happen on every interaction that we are going to do on the existing architecture that currently React Native is doing. I don't believe that anybody in the public have experience with the new architecture. So that's in general how the current versions of React Native is actually handling the ecosystem of doing things. Now comes the new architecture, and the basic question is why the new architecture is here? What tries to solve what problems, and how we can actually, let's say, decide to move towards. As you recall, I speak a lot about the bridge and all this async stuff. So first thing is that there is no longer bridge. That's been totally gone. The second part is that re-rendering infrastructure is rewritten for more cross-platform way. In the previous iteration of React Native, a lot of native representations were done specifically for Android and for iOS. Now they are just kind of going into more general type of direction. So some of the optimizations that were done for Android or for iOS now are available for both of the platforms. Another thing that is very important with the new architecture is the codegen. And this is type safety. What codegen actually does is that it's the backbone of a lot of new functionalities that are built with the React Native new architecture, and it kind of creates a boilerplate code for us. It's not mandatory to use on a new project, but it's very helpful. And then the React 18 is available only with the new architecture. That's very important thing, because with the existing architecture, even if you try to update the version of React to 18, still in the package.json you will see that it's React 18, but in the background it will actually downgrade to previous versions. This is something that is only available with version number 69 of React Native that is fully supported with the new architecture. Maybe also an interesting topic to mention here is that why this change is happening is that dramatically increase the performance of the native site and how things are handled. So it's a good selling point or a good starting point when you're starting a project from scratch to start with the new architecture. If you want to think in a direction that we have a large application that was developed over the years and now we need to migrate it to this, you're not going to find a lot of useful documentation over the net, and it's kind of back to the basics. Everybody needs to learn its own things and learn from the mistakes and then move forward. Personally, we had not so good experience with going forward with the migration on an existing project, and we decided to wait a little bit more because we have a lot of bridging done for native libraries that are not supported from React Native. As you're aware, you can take a native libraries, create your own custom bridge, and then use it inside your application as part of the inside the React Native code, inside the JS. If you are kind of having this type of applications, that I will say that maybe the time is not yet come to start thinking about migrating, because you will need to rewrite a lot of code. But if your application is only dependable of React Native modules, then it's not going to be a brainer or a problem to go forward. So all of this, it's with the new architecture, all of this is actually backbone to the JavaScript interface. And what is JavaScript interface? That's the key point. So when you will go to some different lectures for React Native new architecture, you will hear about bridgeless, turbo modules, etc., etc. But all of them are based on the JavaScript interface. And what this JavaScript interface is doing is exactly what we have currently in our old browsers. So if you open your browser and you type something like document.get attributes or whatsoever, create attributes, you will see something in the console output that is referencing to a native function. And this is what actually JSI is inside React Native. It's an interface in C++ that is actually going to hold reference to the native functions. So that's how they manage to move the bridge away. So there is no longer need for serializing, deserializing JSON objects, passing information, passing events, etc., etc. Now everything that is going to be executed on the native UI thread is going to be communicating directly with the JS thread via the JSI, via the JavaScript interface. So this opens a lot of possibilities. No longer needs for creating some weird logic for waiting async events and then reacting on them. Now this is no longer needed. You can invoke them when needed because you're communicating directly with them. And then comes the code gen. So code gen is, let's say, most overlooked component with the new React Native part, but it's very important. So for example, if you want to define a new turbo model, you will create a function for this new turbo model, etc., and register in your React Native code. So this is more familiar if you are doing a custom bridge previously with React Native. So with code gen, what we have is that this will generate specific platform code for Android and iOS, and it will focus only on the function, like I have at A and B, and then what it retrieves. And this will create our boilerplate code. Currently it's with Java and with Objective-C. There will become iterations that will come with Swift and Kotlin. But it will generate the stack trace, all the implementation for us, so we are just, as developers, need to go and write our code base for the method itself. We don't need to create all this boilerplate code. And a lot of the functionalities that Facebook did for the new architecture are actually relying on the code gen. You are not obliged to use it, but it's very handy tool. I already talked about the fabrics, what fabrics is doing and what is going to represent, and what is the ability for using the JSI bridge. So I guess in sake of time I will just speed up. Okay? So like I said before, this is going to change how we are going to render the components of the new screens, and basically with ability of the JSI to write our code, and then this is going to be integrated directly on the native UI. And then we have, this will allow more efficient communication between the native and the JavaScript code because there is no bridge anymore. When it comes to turbo modules, I already explained them, but basically these are all the native modules that we are using from the native applications, and it's very good to have them to be lazy loaded, so we don't need to load everything on the start of the application. This means that our application is going to be better on first initialization, etc. A lot of the things that we don't need are not going to be loaded. Additionally, we can hook up directly to the events or the native controllers of this via the JSI and then decide what kind of actions in our business logic we want to do. So these are the two new things that are actually derived from the JSI. And this is how the actual new architecture will look like, or it's looking like. And as you can see, there is new segment in the middle. So as previously was mentioned, we had the JS treat, then we had the bridge, then we had the shallow treat. So now this is all changed. So we have the JSI segment here, that is a JavaScript interface that actually is going to communicate with every JavaScript engine that we have. And then this JSI is going to represent its own things towards the fabrics or the two models. Fabrics is going to be responsible for communicating with the shallow treat and actually creating all our native UI, and then it will go to the native UI and native UI models on the representative platform. So it's far less complex and it's far more scalable or stable. So we can think about now implementing more, let's say, better looking applications with animations, creating more, let's say, demanding user journeys, etc. So what we need to look for. So this is the timeline that currently is. So basically, the new architecture was available to the general public with the version 68, and you can actually trigger it with adding a specific flag when you want to initialize your application. But the only catch is that with the version 68, it's only available with React 17. With the version 69, we have React 18 support, and then we have bundled Hermes. So Hermes is something that is very key point to the entire new architecture stuff used on previous projects, etc. But Hermes is something that Facebook is going to offer support for future, and all the optimizations that are going to come after version 70 will be actually tightly coupled with Hermes, and support will come for Hermes. Why they decided to have a bundled Hermes? It's because historically, if they didn't bundle it, they have a lot of problems with different React Native versions and different Hermes. They are not acting very good. So they decided with each version of React Native, when you are shipping your application, that you will ship also a bundle of Hermes. And this will actually, they are claiming that it will not increase the time of building the application, but it dramatically increased the time of building the application. So I think 40 minutes, something like that. Yeah, but it's a good stuff. So I don't think that you should opt out not using the Hermes. And in addition to this, it's very important that this is optimized for iOS. As you're aware, iOS virtual machine for JavaScript is something that was not allowed to be switched. Now they allow it to be pushed with Hermes. And with version number 70, what they will do is that with the changes introduced with 68 and 69, these are all versions that are going to allow developers to migrate their code base towards the new architecture, and a lot of extra stuff is going to be generated. But with version 70, they are going just to get rid of all of this, because they are going to allow CMake support. They are going to unify the CodeGen configs. Now, CodeGen configs still are different for iOS and Android, so you will not need to write double the code anymore. And what they will going to do is that they are going to fix all the transition from old to new architecture that happened from 68 and 69. This is more in response to the bundlers that are used, etc., etc. So they are moving forward with React Native Gradle plugin. So a lot of stuff that is going to be generated to support this kind of migration towards 70. So like I said in the beginning, so version number 70 is available. They were announcing that it's going to be available in the next year, but they actually released it. I will still not go and blindly start it because there is not a lot of community support. If you go to the React Native documentation, you will see that there is a lot of missing information. It's just random script, and they are actually inviting developers that are trying or building React Native applications with the new architecture to actually contribute to their own documentation, or at least to give proposals. Also, you can follow the links on React Native Devs versions to see how they are going to be released. But like I said, we did try on version number 69 because we wanted to go for React 18. It turns out that after a sprint, we decided that it's not worth it because we're not getting anywhere. And we decided to wait until the spring to get more stable versions of the new architecture and at least more stable support for third-party libraries that all of you are using in your day-to-day life. So that's also a key point that you need to think about. Okay, something bonus. And this is very important topic because we all as developers are going to say or put a blame on the frameworks that we are using, saying that, I don't know, React Native is not good because of the bridging, etc., etc. But all of our drop performance or what we are trying to fix in our current React Native applications is actually we are trying to fix our own JS code. So the biggest drop of performance is something that we poorly developed some business logic or we didn't anticipate what will happen when more users will come to use the application, etc., etc. So these are some two useful tools that you can actually use to improve your performance of the application. One is Reassure, and this package actually will allow you to do performance testing on your application that can be utilized with the integration test that you're writing inside your application or unit tests. And this will give some measurements about screen loading times, API calls, etc., etc. So you will be aware where the weak spots of your applications are, so you can actually improve it. Other thing is that obviously we need to use a lot of good stuff when we are coding our application in order to have better performance. It's like memoization on the right places. A lot of people are using memoization because they saw an example, but they don't know what actually is doing in the background or where to use it or how to use it. That's also important stuff. Also, to observe render patterns. So a lot of people are struggling. I can tell this from a day-to-day perspective. A lot of people don't even look how their re-renders happening inside their applications. And React Native and React especially is well known that if you do something wrong, you can have re-renders of your child components for 2, 3, 5, 10 times, 100 times, etc., etc. So all of this is drop of performance, and this is basically of not doing your JS code correctly or React code correctly, and it usually comes that the platform is not okay. So keep attention. 80% of the drop of performance are inside React Native applications are coming from the JS side of the world, of the React code. All of these improvements are just to create your application faster, but if you cannot still write good React code, regardless of what you have under the hood, the application will not be good. Another thing is that this is a Microsoft explained library, the DevCheck. This actually is good for React and also React Native. It's actually going to do a quick check or a swipe with all your dependency packages that you are involving inside your application, because in a lot of cases, our dependency tree can grow hugely, and we can have transient dependencies between different libraries. So basically this helps out finding all of these kind of spots where we can actually minimize the number of packages that we are using, therefore minimize our bundle size when we are actually going to load it to the React Native application. So yeah, that's it, what I have for you. Okay, so questions?
So I have a question, maybe it's out of the scope, but based on this new architecture, how it compares with other platforms such as Flutter in terms of performance?
So I had a similar question previously. So a lot of this stuff that is happening with the new architecture is already something that is happening with Flutter. So I have a colleague here that is laughing. But like I said in the beginning, I don't know how of you remember AngularJS and Angular 2+. So when AngularJS was struggling with performance and they came up with Angular 2+, a lot of people were already switching towards React. The point here is that this React Native new architecture is here for a purpose, and if we are happy with what was done with the old architecture, we should continue working with the new architecture. There will be always something new and maybe better performing, but this doesn't mean that we need to dump our entire code base or project that we built for 2 years and then just say, okay, we are going with Flutter because React Native is no longer an option for us. And performance-wise, if you are building a complex applications like gaming applications, the new architecture will be neck to neck with Flutter. But if you are building a business type of application with input fields, drop-down list, etc., basically the biggest drop of performance is on the JS side. So it's not on the native part of the application. And having the JSI introduced, it will solve a lot of these kind of problems that we were previously facing. Like I said, the JS is the key for performance. So if you're not good with understanding React as a technology and how re-renders happens and what is memorization and a lot of other stuff that can come from the JS code as a general issues, regardless of what you have on the other side, the application will suffer from performance. I hope it's good. Maybe a keynote. Do try the new React Native because it's going to be a good experience for you as developers. It's something that you cannot find examples on Stack Overflows or a lot of other places. So you will need to put your brain into action and actually develop something. So it will be a good experience. Yeah.
So Facebook is not in a good position right now, right? So they lost, what is it, like 2/3 of their value or even more. What happens with React if Facebook fails?
I don't think that this as a technology will just simply go away because there is a lot of community around it, especially around React. So I don't expect that if Facebook dies, I hope, that this will happen. Unfortunately, we kind of saw something previously like this with Ruby that happened, but I don't think that it will go away so easily. Even now, you're using Ruby with React Native. CocoaPods is Ruby based. So, yeah.